Okay, are we set? Let's tell me. And okay, you chat me if I missed you. I think I got everybody. Let's just make sure. And okay, I'm going to do old things because there's no point in introducing anything new before a midterm test. Bilal, tell us your time and for tomorrow. Just we like to hear your voice, and it reminds us better.
Sounds good. Can you hear me?
Yeah, I do.
Awesome. So just to remind everybody that tomorrow at 11 a.m.
Hey, wait a minute, Bilal. It sounds like you're in a tunnel. The audio, the audio is feeding back into your mic, I think, and it sounds like you're in a in a cave. Try again.
How about now?
Oh, that's wonderful.
All right. Sorry, I didn't have my headphones in. Anyways, so tomorrow's SI session will be at 11 a.m. You guys should definitely show up if you can and are available to, because we are doing review that will most likely help you on your concept exam. And also, just a heads up, Professor, I was sending you an email. My Wednesday SI sessions are going to be pushed back from 5 till 5:30 going forward due to scheduling conflicts.
Okay, I'll update the website. 5:30 is the start time
Correct.
for Wednesday.
And that's it. Hopefully see all you guys there tomorrow morning.
Excellent. Thank you, Bilal.
No problem.
Okay, class. So what I want to do, I have, if I have out of the what 35 of you that are enrolled here, if 6 people all come to me with the same issues, then I know there's like 26 others who haven't brought it up with me. So apparently this is a very confusing document and it needs to be reviewed. And you'll see during this review, we'll relearn some memory management techniques, some memory structure is involved here. So let me let me get my copy of this so I can share it from time to time. Um, where did I leave it? Okay, move to 4. I think this is okay. We're going to make sense out of this. So put this over here. This is out of the way. And okay, so everyone, let's. I'm going to be switching back and forth between my whiteboard and the assignment 3 document. Let's start here. Assignment 3 here. Okay, let's make sure it's all clear. It starts out by saying, set up these commands. So you run your assignment 2 in GDB mode. That means for practical purposes, you need to make a new bash file and just make it slightly distinguished from the previous one. So new, I'm writing where you can't see. I'm writing on the whiteboard that's on my desktop, but then I'll switch back and forth. You make a new bash file and give it a slightly different name. Um, I mean, I'm not very creative, but I just take the first name r.sh and create it rg.sh. But you can call it whatever you like. Okay, then it says, so you prepare the bash file. You remember, every line gets a hyphen G, except the NASM line gets hyphen G hyphen G dwarf. Okay, that becomes your new bash file. Okay, so it says run the program in GDB mode. So that, in other words, line 2 up there says run your new bash file. So run your new bash file ./rg.sh. Okay, we assume that the program itself from assignment 2 doesn't have bugs in it. It's compiles and executes cleanly. Okay, so GDB starts up, and it's the program, internal program, which is old assignment 2, hasn't executed yet, but you have you have an opportunity here to set breakpoints. I suppose there might be other parameters, but I don't know of them. So step 3 and through 4 or 5 talk about making breakpoints. I know you can't see what I'm writing, but hang with me and you will. So that's, if we put line numbers on this, so this would be line 1, this would be line 2, this would be line 3, 4, 5, 5, 6, 7, 8, and 9. Okay, so lines 3 through 8 are to make new breaks. It's an exercise in having that experience. You need to, even if you don't use them later, you should know how to make them. And there is a way to remove it, but let's deal with that after you can remove breaks too. We'll deal with that after the midterm week. Okay, then line 9 says, show all those breaks. You can go back and review your work. Show them. So making breaks is the letter B followed by a line number or a name or a called function. I think you've seen me do that many times, like break space a line number, break space a name. There's no colon in here, it's a space, and then a name like main. Okay, so there asks you to make 6 of these, and number 9 is show them all, and that's an IB command. Okay. All right, well, then we come to the, I kind of group these into phases, so-called. Next would come line 10, line 11, line 12. Okay, begin execution. Line 12 is the letter R. Simple as that. Okay, there's no ambiguity there. Line 11 says you have to find the statement in your source code that says welcome to, I forgot the rest of the sentence. Okay, so let me back up, show this, begin execution. How do you get there? I had in mind when this happened that 11 you would press N several times. And you keep watching with your eyes until you see the statement that's probably a printf or a cout that says welcome to program assignment number 2. So you press N slowly, repeatedly until you come there. And this is not clear if you're supposed to execute that statement or not. Okay, so in an upgrade, this is going to be advanced to the statement that does this and execute that statement. Okay, so we want to advance forward step by step until you come there. Okay, number 12 says output the contents of RSP in hex. Okay, what do we do there? You enter 12 P/X $RSP. Okay, so let's switch back to my sloppy handwriting. Okay, so 3 through 8 ask for this. It's like this circle here, not that scratched out piece, but a B space something, usually a line number, usually a function name. If you have markers in your assembly, you could put a marker there. What is a marker? A marker is a name that you insert in the segment text that just marks the location. So it could be like inquire. And you put 2 dots after it. And it's a non-executing statement, but it marks the location. And if you want to break on that name, you could say break inquire. All right, INQUIRE. The name of the assembly function that you're calling is one of these. It's the first one below segment.data, segment.text. And you can break on that one. Break on, what was assignment 2's name? A2. Okay. Where that's a marker, and this is a marker. And you can break on names of functions and line numbers. Okay, so we're past that. You run the program, line 10, you advance forward, line 11, and then it's asked the question on line 12, show me the contents. There's the answer. Let's go back to sharing. Okay, here it is. Okay, so line 12. Output the contents of RSP. Let's mark it 13, and on my page that would be 13 is P/X $RBP. Sounds okay. So far, not big ambiguity, but it gets worse according to your comments you've been sending me. Output the contents of RIP. It follows the pattern of the previous one. 14 would be P/X $RIP. And we should recognize RIP. These are usually very small numbers, small, like 6-digit numbers. It's in the low memory addresses. And I'm writing these notes, but we'll see them in a moment. When you output RBP, it's usually a huge number. This is large. It could be what could be 12 hex digits. You know, it's typical size of it. Okay, and output the contents of RDX in decimal 15. So 15, it's asking contents. It's just what number is held in RDX. Well, P/D $RDX. Okay. advance to the statement that outputs welcome to this, and just we're still inside of C++, right? Not C++, inside of C. Phase 2 up here. These statements are supposed to be executing inside of the C language program. Okay, so 15 asks for the decimal output, base 10 output. That's not confusing. 16. I was expecting that you would use the letter N, meaning next, repeatedly until you come to that statement. And then when you come to it, use N one more time to actually execute that statement. Okay?
And Professor,
Okay. Yes.
shouldn't line 14 be PB because it says print it in binary?
Ah, 14. Yeah, yeah, yes. I don't know. Some people say my eyesight's failing, but okay. Yeah, let's verify this. Line 14 says binary after it. Okay. So here we are, backing up. Number 13, P/X, you get a big number, 12 digits. Next one, PT, RIP. Now my comment here is kind of off. If it were in hex, this would be 6 hex digits. In binary, what is it? It could be 48, somewhere in that order, 48 bits. Okay. It's still a relatively small number compared to the previous registers we're looking at. And then we do this one, and you look at that one, and then your eyesight, you have to watch until you come, use your eyes open and press in, not fast, but until you can see that the next statement to execute is a welcome statement, and then go ahead and execute it. Yeah. Thanks. Okay. Okay. Number 17. 17 says output the size of the system stack. In truth, that doesn't make a whole lot of sense. 17. Okay, I guess let's pause here and understand the terminology. Okay, let's go over that memory organization for a moment. Okay, so let's say you had 8 gigabytes of RAM. So this number out here is this address is the 8 billion it's number 8 billion. Minus 1, because it starts counting at 0. But you get the idea. That's the very high number. Your last quad word has an address that's close to 8 billion, and we say you have 8 gigabytes of RAM. Okay. Now, this top area is just generally called the stack or the system stack, to be precise. System stack. And I don't know how to get that last address precisely in software so that it would run on a 4 gigabyte, on a machine with 4 gigabytes of RAM or a machine with 24 gigabytes of RAM. How do I get this last one? I really have never tried to investigate it. So that's why line 17 in your homework, it says output the size of the stack. That would be how many bytes between here which is top, and here. Um, that question needs to be changed, and let's see what's a candidate to be more useful would be output the size of the current activation record. C-U-R-E-N-T. Let me see. That's doable. Okay. So what is the story of activation records? Uh, the stack itself is composed of, it's blocked off logically. Well, not a black ink. I got to do something else. Hang with me, everybody. Let's see if we can make this work. Okay. So there's activation records, which is a contiguous group of bytes that comprises stack, and the one nearest the top of the whole system stack, namely this one here, is the current activation record. The others are dormant or sleeping. So if you had a program main, and main called A, and A called B, and B is currently executing. We have this chain of calls. B is currently executing. Then B owns the activation record that's cross-hatched out. It owns that one on the top. A owns the activation record that's dormant because A is not executing. And M owns the activation record back here. So what's back here, I don't know. I've never seen anyone describe it. I'm sure there's some stuff back here. So probably stuff that belongs to the operating system. It's running processes all the time. So when your program starts, the first activation record is created because main hasn't called anything yet. So it allocates a chunk of memory space on the stack, and that becomes the activation record of the process that's currently running. And at the time, the top of system stack matches top of current activation record. See, there's an overlay. Let's get our terminology here. Okay, let's say C is called. Okay. Then who allocates the space? The runtime system looks at the static data in C and counts up how many bytes it will need and allocates that much space instantly at the time of call. It's all created. And the top of the system stack is here. That's RSP. But it also coincides with the top of the newest activation record. So can we call the top of the activation record the low address part of it? In black, that's the top of the activation record. This is the bottom of it. But I also hear people call it the back of the activation record and the front of the activation record. This is front end. Low addresses. This is back. Higher addresses. Okay. So RSP marks the overall stack. RSP is going to be changing as these activation records are created. It will move to the front of it. There I said the word front of the activation record, and always stay at the front of the current one. And this red line points to this hashed out one right there. Okay. Well, when function C terminates, all of its stored data goes poof into outer space and it disappears. Then this one resumes execution. All that. B calls C, C does its job, and C returns anything that it's supposed to return. B resumes. All of C's activation record disappears. Its declared data and local variables are gone. Okay, so at that time, when C returns, RSP will jump back to here, and I haven't mentioned RBP yet. So RBP is a marker, is a pointer to the back of the current activation record. I'm gonna put it in black. It's right here. RBP. RBP is the back of the current activation record. Doesn't know anything about the others. They're out of the picture. RSP is a pointer to the front or the top, same thing, of the current activation record. Okay, so let's go back. The question was, I think we're here. I hope you're seeing the screen where my mouse cursor is. I gotta spell it right. Okay, so number 17. I'm going to make this change permanent and then repost it. That needs to be clarified. And output the size of the current activation record. We did that last class meeting or in a recent class meeting. That's B/decimal parentheses $sign or the large number RBP minus $sign RSP close parentheses divide by 8 and plus 1. So there's your answer for number 17. Okay, number 18. Output the contents of the pointer to the top of the stack. Let's mark it 18. Okay. This is different words that's trying to ask for the exact same thing we did a little while ago. Pointer to the top of the stack. That's this one. So things have changed, or we'll find out. So is this ambiguous? A student emailed me and said, is this statement actually asking for the quad word on top of the stack or just what? Let's make it say this one. It's, I can't do this, copy it. It's actually the same thing. Control C and paste it here. Control D. Okay. And then let's add an explanation note. This is the pointer to the top of stack, which at the same time, it is the address of the front of the activation of the current activation record. Well, let's be technically precise. Address of the front. Activation record. Activation record. Okay. Those two happen to coincide. The back of the stack, I don't know how to get there, but we can get to the back of the activation record. And I think that's coming out, 19 of the current one. There's lots of activation records on the stack, but there's only one that's current, and that's at the top of the stack. Okay, I'll put the contents of the pointer to the bottom of the activation record. That almost makes sense. It's asking for, I'll record it here. We'll look at my records in a moment. Number 19 is asking for the contents again. It's not what it points to. 19 says, give me P/X $RBP. Okay. Then it's, okay, I'll put the contents of the pointer to the bottom of the activation record. So that assumes you know the terminology. Bottom of activation record is the back end of the activation record. And pointer to means you're going to get some address when you output this. You won't get the actual data stored there. You'll get an address, and that's what's expected. So does this need clarifying? BOTTONAR is same as that R, and the pointer to that is RBP. RBP is that pointer. Okay, I haven't been diligently watching the chat messages. Occasionally questions show up. Okay, so let me look back. Okay. Gilbert had a question that's already been answered. Mark, I didn't see your message until I intentionally looked. Let's fix that, even though it's late. Sorry. Yeah, sorry about that. And that's we caught up. Okay, 19. Number 20 is here. 20. Output the quad word in this. Output the top quad word in the stack in hex. Okay, so okay, you can't see it yet, but I mean you can't see my diagram. I'll make a diagram and we'll switch back to it in a moment. I'm drawing a stack upside. Here, let's switch right now. Okay. So we're doing number 20. Here's the stack upside down. The top of the stack is here. And very technically, it's the address of the corner on the right side. This is all that little Indian stuff because we're going to access increasing addresses as we go in that direction. Okay, so the question is asking, number 20, the top quad word. That would be this whole, in picture form, it's this entire thing. You know, I gotta throw this away. I had a good one here. Oh, okay. Well, even that doesn't help much. Why can't I ever buy dark markers? I don't know. Bear with me, everybody. This is an ongoing battle. Does this do it? I wanted to circle this. Okay. Assuming every drawn row is a quad word. You could draw this stack in where there's individual double words or whatever, but quad word is the nicest representation. To say, when the question says output the top quad word, it means output this one here. Okay, and so our response would be X/1 quad word written in hex of 8 bytes. That's letter G, $, RSP. Okay. If you wanted to see it in plain ordinary integer decimal, now that's what the question asked for. So now we're going off into learning things. One group, I don't know what they call these. One group of output would be a letter D. G stands for 8 bytes. That's a quad word. $, RSP. And you'll see that number in the dark box appear in decimal, integer decimal. What was I going to do? What if you just wanted half of that? Okay, so I take an imaginary half. Where did that? Let's cut it right in the middle. Okay, so this half over here is 4 bytes. The whole quad word is 8 bytes. We want 4 bytes of it. It would look like x/one object. It's did we specify what numeric form? Let's look at it as unsigned integer, and then the one below G is W, RSP. Okay, so in your scratch notes, for GDB usage only, the order is B, I hope I get this right, H, W, G. Okay, bytes are 1, 2, 4, and 8. Okay, this doesn't apply outside of GDB. A word outside of GDB is actually 2, but in this system, it's a 4. Okay. So that would just take these 32 bits and give you an integer out of them, regardless. Or if you wanted, what if you wanted the first 4 quads on this stack? 4 hex G $, RSP. Okay. So none of these in front of you output what's in RSP. They output what RSP points to, and then in the last case, you get some extra. In the last case, you get 4 groups, which are quad words. They're quad words, and they're all each expressed in hex, and this says that they're quad words. All right, so let's get back to number 20. Number 20 asks for this answer here. Okay. All right, I'm going to go share back to the screen. That's right. Number 20. What's 21? 21. Output the bottom quad word of the current AR in hex. Okay. Well, who tells us? One register tells us about the bottom, which is also known as the back end, and that's RBP. So number 21 would be X. Let's do the wrong one first. If you use P/X $RBP, you get the address of the quad word at the back of the activation record. That's not what this question asks for. This is not 21. So 21 is asking for a dereference of a number. That means go to the address, treat that number as an address, and then go to that address and pick up your data. That's the X slash, I think we want one of them, XG $RBP. That's what I, I'll put the bottom quad word of the current. I think that's this non unambiguous. I think so. Okay. Okay. Now we jump to 22, and it assumes in yellow highlighting that you've entered the triangle .asm. So 22 will be navigate forward until you, oh, you're, okay. This is important. 22. To leave the C program and enter the triangle in assembly, it says navigate forward to the call to the triangle program and then enter the triangle program. So what that was intending for was that you press enter several times, and when it pops up that shows calling the triangle program is the next thing to execute, then you use the letter S. Okay, so this is going to look like, I don't know the count. You have to watch it with your eyes. Count. You press N and see the next statement to execute. Press N, press N, press N. And when you see that the next thing to execute is call triangle, it'll be something like, here we go. Area equals triangle. So when you see that one, then you use this one. Okay, that's what it says, and I'll go back to walking through this. Navigate forward and enter the triangle. Okay, now several students have emailed me saying they found flaws that S doesn't work correctly. That will take a lot of research, but I'm quoting you what the reference manuals say. The reference manual says that when you come to a function call of any kind, even calling printf or calling your triangle function, to enter that function and step through it line by line, you should use the letter S. So a couple that have been sent to me, it's backwards. They're using in to enter it and step forward without entering it. Okay. Those are rare cases. Standard processing is you press the letter N and it will execute the next statement. If the next statement is a call to a function, it will execute the entire function without showing you step by steps. If you press the letter S and you're not at a function call, you'll just execute the next statement. But if you aren't a function call and you press the letter S, then you'll step into that function and you'll be able to use letter N and go through it line by line, statement, instruction by instruction. Okay, so number 23. 23, that's tedious. You have 15 pushes or thereabouts. 23, press N repeatedly until you get past all those push-ups that are doing backups. Okay, 24. Okay, so I think this is unambiguous. You want one command that shows you all the GPRs. 24. It surely must be IR with a space between them. R is for register, I is for give me information. Okay. Use the name of the initialized string to output the characters of the array. That's 25. 25. Okay, so for this discussion, we need a name of a string. Use the name of the initialized string. What shall we say? This is 25. It has a name. Well, we would use something as last, we'll call it last name. Suppose last name is the string. And it says, use the name to output the characters of the array. Okay, I'm betting that is PS space last name. You know, I'm going to check this out. Let me verify that what I just said on a file I had made this morning. And then sure enough, I can't find it. Okay. Where'd it go? I lost track of it. No, I was doing this myself. Where did it go? Stay with me, everybody. I'm looking for. No, that's not it. No. Samples. Okay, maybe I've got it here. Yeah, I think so. Okay. Okay, strings. Let's. Okay. Let me put this where I can talk at the same time. Okay. Let's stop the share. Strings have always been my personal problem. Okay. So this morning I verified what I'm going to show you right now regarding string stuff. Let's see if I got the right route for it. Okay, we have a string called let's say its name is last name. It could come from .data segment or it could come from .bss segment. Okay. Okay. Output the value stored. Well, I better so my notes, we may have to verify this. My notes say the following. It's still not 100% clear. Okay. Output the entire string showing the printable ASCII characters. That is, it's right here. P/S followed by the name of the string. Okay. Output the ASCII code of each character of the string. P/X last name. So I'll move this up. This last one, if that's a test question, outputs ASCII number for each character in the string. Your output will look like 0x23, and there's a space, 0x46, space, 0x, how high do they go? 80. So you're getting the ASCII value of all those letters in the string. This one gives you the printable characters. Please enter, or whatever it's going to say.
Professor, I think it's supposed to be X/S. You're supposed to examine it.
No, I don't think so.
Oh.
You might. Okay. No, it's okay. You ask, Bilal. I'm glad to be challenged. Let's. And I have about 2 more on this list. We better run this live just to be sure. Okay. So my note said, output the address where the first character is stored. P/X ampersand last name. This is address of first character. And now it says output the string of printable characters with the address. I need new paper. Okay. The question is output the string showing printable characters along with the address of the initial character. Output string printable, not ASCII numbers, printable plus address of the first. Okay, so I'm X/1 string shown in bytes, space, last name. All right, well, see, we're on question 25. We're almost done with that list. But strings, more than number arrays are usually clean, but I have issues with how strings are. Let's hang on. We're going to run this and verify that one. So I got to bring the program up in front of you. We'll do this open terminal here. Well, I lost my terminal. Okay. Let's move it to here. And I'm going to, where'd the terminal go? Okay. We want to get there quickly, sort of. So here, let me share that terminal screen. And here. Okay, so we're going to test these. You can't see them now because we're sharing the screen. But there are 4 commands that relate to string data. Let's, okay, so shrg.sh. Oh, wow. What did I do? shrg.sh. Okay. Break main. Let's try to get underway right away. Run it. Next. Here comes a bunch of nexts. Next. There's a string coming up. It's called message. It has to be a static string. I wanted to explain that for the last 5 minutes. There's a string, but it's a valid one called message. Okay, so what does P/S do? MESSAGE. It tells us what's in the string. It's cut and dry. It just gives us the printable characters of the string. The second one I had suggested might be useful is X message. Okay, those are the ASCII values of the letters in the string. For example, the uppercase H it begins with is hex 48. The next letter, lowercase I, is hex 69. Space is hex 20. All right, let's try one more. We want to find the address where this string starts, which can be rephrased as, what is the address of the first character in the string? P/X ampersand MESSAGE. That sure didn't work right. The address can't be 0. Oh, that is it's a typo mistake. Ampersand, not $sign. MESSAGE. Okay. It looks right, but how can we really verify it that that is the address of the starting character of this array? And let's go to x/1 SB message. Okay, so this command x/ outputs both the address and the string. And you notice that address matches the one 2 lines above it. I think it's supporting evidence that it really is the starting address where H is stored. And that's a large address. Notice it has lots of hex numbers in it. It's 8 or 10 digits long. That's so large, it's in the high end of memory, and that's stored in the activation record. It says this array has all of its data stored in the activation record of the function that created it. So that leads us to the definition. I think everyone, we're done with. Bilal, did you want to suggest another command that we could test here?
Not
X/
command,
something.
but there is, so the commands you're using right now, they work for your variables inside of the C file, but once you go into the assembly file, those print commands no longer work the same way. So if you try to print the variable in your data section, those commands don't work. They want you to cast them.
Oh gosh.
So that's why I was saying you'd have to use the examine.
Yeah. Oh gosh.
So if you want to just continue to your assembly file and step into it, and then just try one of the variables in it.
I believe you, because it's coming back to my mind that I had that issue with strings. I've been saying that. Can we? Yeah. Can you all see? We're sharing that, I hope. Okay. Next is something else. Next, and next, and next, and next, and next, and next. Here's a call to assembly. S. Okay, so next. Let me get past some of these things. We don't have to go the whole way. Okay, so I need the name of a string out of here. Let me look at the source code so I can pick up a name. Where did I go with it?
Introduction is one.
Okay, so introduction is one. Yeah, that's a good one. Okay. Okay, so how come that's sort of off the edge here? I hope everyone can see my terminal window here. Okay, so in I, what are we at? We're here. So one of the commands I gave was p/s introduction. Bad luck. Oh, geez. do these others fail? p/x introduction. Hope I spelled that right. Have to cast it. That's where you cast to char star, I think. Well, p/s star and introduction.
You have to give it the address.
You need the ampersand on
Did
there.
I need it? I think I need an ampersand. Okay, ampersand. It's not great. It works. It's satisfactory. Okay, class. My if you're recording this, those answers I wrote in brown marker appear to apply only to C and C++. So you can't see it, but let's start another list. It was P. Oh, I still use P/S. I can't. That's not the examine. /S. Okay. Char star ampersand and introduction. Okay, you can't see it, but I'll show it to you in a moment. Does let's try the example on that. X/ we want 1s. I'm not sure what to use for G. GR star ampersand INTRO.
You can also just use instruct XS.
Shorten it to XS. Nice to know. /S. Again, CHAR star.
Oh, you don't need the star, the character anymore.
Oh, with string with S, you don't?
Yeah, with string, you just have to put the ampersand and then introduction. We still need the address though, ampersand.
Okay. Ampersand, thanks. That gets us the same answer. Okay, that looks pretty good. For the record I'll show this in a moment for those who are recording it. It's X/S, only ampersand intro. So P/S needs casting into char star, but X/S only needs the address, meaning an ampersand of intro. Okay, is it? Yeah. So what else did I use? I used P/X with an ampersand. Does that fail over here? Previously in C++, I used P/X. Where was it? Ampersand, the string. Ampersand, INTRODUCT. Okay. Yeah, that one matches with C++. Gives the address of the first character. And we're off track. We're off the subject. I better record that. That was P/X ampersand intro gives address. This matches with the C++ version. Address of first character. Address of the string. And let's match it with the fourth one I used. X/1SB. It outputs the string and its address. So we'll see what happens here. X/1SB intro. If that actually worked in C++, but here it needs the casting. Let's give it a try.